I'm going to continue on with the review sheet. Sorry if you got that last video that had a frozen camera and no sound. Had some problems at school, so I'm trying this at home. For each problem, find the particular solution to the differential equation that satisfies the initial condition. So we're going to find a particular solution. This says f prime of x equals 4x plus 2. My initial condition is f of negative 1 equals negative 3. So to find a particular solution, you integrate. Integral of 4x, 2x squared. Integral of 2 is 2x plus c. That is the general solution. The particular solution would be if you plug in f of negative 1, you get negative 3. And then we solve for c. So this is 2 minus 2, which is 0, so c is negative 3. And your final answer would be to write the function and put in your c value of negative 3. And then that is your equation. That's a initial condition satisfied. Going to the next one. Evaluate each indefinite integral. It's a chain rule problem. Let u equal 3x plus 1. So du equals 3 dx. Solve for dx. And when we go to substitute, you have 3x u to the fourth, I think. I can't really read that. And dx is du over 3. So what happens here is that you can cancel out the 3's, but we still have an x there, so we can't integrate with respect to u when there's an x. So you go back to your original substitution equation and you solve that for x. So u equals 3x plus 1. That means u minus 1 equals 3x. X equals u minus 1 over 3. So my integral becomes u minus 1 over 3 times u to the fourth du. Now I have all u's I can integrate. I'm going to distribute the u to the fourth. I'm going to take out the 1/3 all in one step. So that would be u to the fifth minus u to the fourth du. So 1/3, this is going to be u to the sixth over 6. So I'm going to put my u back in. So 3x plus 1 to the sixth over 6. And then u to the fifth over 5. So 3x plus 1. Probably won't see it in this form if you check the answers in the back of the book. You can distribute. If you distribute here, I think they have the answer that matches on this page. It's indefinite integral, so you have plus c. Number 19 is finding the average value of a function over the interval, and that's just the formula 1 over b minus a, so 5 minus 2 times the integral from a to b of x squared over 2 minus 2x minus 3 dx. So in other words, whatever we get for our integral value, we're going to divide it by 3, 1/3, and that's the width of our interval. So to integrate, x squared becomes x cubed over 6, x squared, and 3x. We're evaluating at 5 and 2. So 5 to the third is 125 over 6 minus 25 minus 15 all over 8 sixths minus 4 minus 6. So we have our first, that's our f of b, f of a. Maybe if you don't want to get a common denominator, the best way would be to combine your whole number or your integers first. So negative 40, and this is negative 10, so negative 40 plus 10 is negative 30. And then we have 125 sixths minus 8 sixths would be 117 sixths, and then you can get a common denominator of 6. So you have negative 63 sixths, and then that is going to be divided by a third. Which 3 goes into 63 21 times. Negative 21 sixths divided by 3, 7 halves. So negative 3.5 is the average value of the function over that interval, average y value. The last portion of this worksheet is definite integrals, and it looks like we maybe have a u substitution, and so we'll practice leaving it in the u substitution form. So always go to the power first for your substitution. So u equals x squared plus 1. So du equals 2x dx. dx equals du over 2x. Integrate negative 1 to 2. 4x u squared du over 2x. So our x's will cancel out, so we just have a half integral from negative 1 to 2 of u to the negative 2 du. Now at this point I'm going to change the bounds because I don't want to plug everything back in. So I'm going to change the bounds by plugging in my original bounds into u. So I'm converting everything to u. So instead of negative 1 here, it's going to be positive 2, and up here it's going to be 5. So when you integrate, integral of u to the negative 2 is u to the negative 1 over negative 1, or just times negative 1, and then we're going from 5 to 2. So this is one where it's probably easier. It's not that much different either way. 1/2 u to the negative 1 just means 1 over u. So this is negative 1/5 minus 1/2. Sorry, plus 1/2 because it's minus a negative. That's 2/10 minus 5/10. Negative 2/10 plus 5/10 is 3/10 times a half is 3/5. That's not it. Sorry, some of you thought you were getting extra credit there. I caught it. This should be a 2. 2. It feels good to feel like you're going to have some of that power though, right? Negative 2/10 plus 5/10 is 3/10. 2 times 3/10 is 6/10. 3/5. Lots of places make little mistakes, especially if you're listening to classic country in the background. And try not to play too loud so you get copyright laws. For the second one, I'm going to let u equal 2x to the third minus 1. So du equals 6x squared dx. Dx equals du over 6x squared. Substitute. 18x squared u squared du over 6x squared. X squareds cancel out. 18 over 6 is 3. Make sure you have it right this time. U squared du. Let's go ahead and practice changing the bounds, so when you have to do that, you know what you're doing. So if I'm changing the bounds, I'm plugging in -1 into 2x cubed minus 1. That'd be -2 minus 1 is -3. And then I'm plugging in 0, and that's -1. Not sure it makes it any easier on this one. 3 u to the third over 3 -1, -3. Before you plug everything in, if you want, you can see that. Then it is easier. -1 minus -27, which would be 26. Last but certainly not least is the review of the most fundamental question from the first trimester, which would be finding the equation of the tangent line at a given point. F of x equals -x cubed plus 4x squared minus 3. So I need to find f prime, which is the slope of the tangent line at any point. Plug in -1. And that gives me the slope of my tangent line, which would be -11. Then y minus y equals slope x minus x. Big shout out to your algebra teacher for teaching you how to make an equation of a line. You can leave it like this, you can change it. Sometimes it looks like this form, sometimes it's in slope-intercept form. Probably says in the question which form to put it in. -11 plus 2, -9. If you graph both this cubic and the line, they would intersect at that point. They might intersect some other places too, but there would be a point of tangency there.